Okay, number 12. Consider the following chemical equations. Select the equations that represent physical reactions rather than chemical changes. I kind of think you meant to say chemical reactions rather than physical changes. But okay, so this first one is a chemical change because we're creating new products. So if you look here, we start out with a hydrocarbon and oxygen, and we create carbon dioxide and water. So this is a chemical reaction. And then for 2, we have the same chemical formula. The only thing that changes is the phase, and a phase change is a physical change. And then for 3, NaOH is broken up into its ions, and we know that those can just reform back into NaOH. It doesn't create anything new, so this is a physical change. Oops, physical change. And I think that maybe the question was worded wrong, because the answers, if we're looking for just physical, we should be only having 2 and 3, and 1 is in all of the answers. So I will email him about this question. But as it stands, if you have any questions about why number 1 is a chemical reaction and why 2 and 3 are physical changes, just let me know. Number 13. According to the following equation, how many moles of water are made in the combustion of 10 moles of glucose? So remember, when we're given something to find, we want to put that on the one side of the equal sign. So we're looking for moles of water. And then the next thing we put is what we're given. We're given 0.10 moles of glucose. Okay, how can we get rid of moles of glucose? What can we multiply it by to get rid of moles of glucose? Well, nowhere in this problem are we dealing with any type of mass. So I think our first instinct is to do the molar mass. But we're looking for moles of water from moles of glucose. So in this regard, can you think of anything that would change moles of glucose and provide us with moles of water? So if you're thinking of mole to mole ratio, you're on the right track. How many moles of glucose do we have? Well, remember, when nothing's written here, we know that there's an invisible 1. So we know 1 mole of glucose will produce how many moles of water? 1 mole of glucose will produce 6 moles of water. Okay, so now we can cross off moles of glucose, and on top we have moles of water. Is that what we are looking for? We're looking for moles of H2O, and on top we have moles of H2O. So now we can just multiply across. We got 0.6 moles of water. Okay, so here he's telling us this equation is unbalanced. So before we do anything, let's balance this equation. So we have 2 hydrogens, 2 oxygens. On the reactant side, we have 2 hydrogens and 1 oxygen. You put a 2 here. Now I need to put a 2 here. And I think we're balanced. Let me write that a little better. Okay. How many molecules of hydrogen will be required to produce 3.20 moles of water? So remember what I told you about when you see molecules or atoms, I want you to automatically think of Avogadro's number. So whatever it's going to be, we know we're doing something with Avogadro's number. So we're looking for what? We're looking for molecules of hydrogen. And it gives us information right here, so we know we want to put that here, 3.20 moles of water. Okay, what can we do to get rid of moles of water? And remember, it's always our instinct to immediately go with the molecular weight, molecular mass, but nowhere in the questions that have anything to do with grams. So if we want to go from moles and we want to get rid of moles of water, what can we put on the bottom and on the top? Just like above, we're going to do the molar mass. So how many moles of H2 are produced from how many moles of H2? So we get 2 moles of H2O for every 2 moles of H2. Okay, so now we can cross off moles of H2O. Perfect. We have moles of H2 on top, but we're not done yet because we need molecules of H2. So remember, when we look at molecules, we're looking at Avogadro's number. So how do I get rid of moles of H2 on top and replace it with molecules on top? Well, we know that 1 mole of anything, so we're going to say 1 mole of H2, 1 mole of anything has Avogadro's number of molecules in it. So now we have molecules of H2 on top. You can cross off moles of H2. And now we can just multiply straight across. And we get 1.93 times 10 to the 24th molecules of hydrogen. So that's B. All right, and I'll stop the video and start another one.